I keep looking at the original pages of the Voynich Manuscript and I just don't buy the hoax theory. For decades, there has been a very vocal group of people who believe this entire book is just a 15th century scam. Now, the theory is that some medieval grifter wanted to sell a fake magical text to a wealthy duke. So they bound together a bunch of prepared calfskin, drew some bizarre plants that don't actually exist in nature, and then scribbled 240 pages of random, meaningless shapes to make it look like lost ancient knowledge. It sounds plausible until you actually stare at the ink. There are tens of thousands of words in this manuscript, written in a fluid, confident script. There are almost no crossed out mistakes or awkward hesitations. Now, if you sit down and try to fake a completely new alphabet for a few paragraphs, your brain gets tired. You start repeating the same loops. You mess up. This book looks exactly like someone writing in their native tongue at speed. But a gut feeling isn't data. I wanted to see if I could actually prove that this is a real language, using the exact same logic I once used in one of my projects. Now, if you saw my video where I converted the text of the picture of Dorian Gray into RGB pixels, you already know the core problem here. In that project, I took a masterpiece of 19th century literature and translated the characters into color math. Now, the resulting image looked exactly like static. When I put it side by side with an image generated from pure random Python math, the human eye literally couldn't tell the difference. The project proved something really important. Highly structured information can look indistinguishable from random noise if you don't have the key. You absolutely cannot trust your eyes to identify meaning. Just because we look at the Voynich manuscript and see unreadable alien squiggles doesn't mean it's gibberish. We have to strip away the visual layer entirely and establish a mathematical baseline. But there's a massive roadblock. When you try to read photographs of something like this using Python, the math gets a bit messy and complicated. Before I could write a single line of code to test the language, these drawings had to be converted into a standard text file so that it could be easier to work with it using code. I obviously didn't do this part manually. Over the years, a massive community of researchers built a system called the European Voynich Alphabet, EVA. They didn't try to translate the book. They just needed a way to type it, so they went through the manuscript and mapped every distinct pen stroke to a standard English keyboard key. Take the very first word on page 1. It looks vaguely like the word for cheese. Now, the researchers looked at that tall swooping shape at the start and arbitrarily assigned it to the letter F. Now, they found a shape that looked like a little bench and they mapped that to the letter C and the letter H. A strange little loop became a Y. This is nothing more than a brute force font swap. It doesn't translate the meaning at all, and the resulting words are still completely unreadable to us. But the EVA transliteration finally gives us a massive continuous text string of data. It gives the computer something to actually count. To find out if those characters are a real language, we need a concept from information theory called the Shannon entropy. The technical definition of entropy is a measure of unpredictability. Now, think of it like a measurement of surprise. If I open a text file and type a string of 10,000 letter A's and then I cover up the last character and ask you to guess what it is, you don't even have to think. You know it's an A. There is absolutely zero surprise. Now, visually, it would look like a solid flat block of color. Mathematically, the entropy score is 0. Now, imagine I close my eyes and just smash my hands on the keyboard for 10 minutes. If I cover up the last character, you have no clue what it is. It could be an X. It could be a 7. It could also be a bracket. So, total surprise or maximum unpredictability. Real human language sits in a very specific, messy middle ground between those two extremes. Think about English. If you are reading a sentence and you see the letter Q, you already know the next letter is almost certainly going to be a U. But not all the time. Now, if you see the letter T, there's a very high predictability the next letter is an H. Now, human language requires rigid, predictable rules so our brains can parse the syntax. But it also requires enough variation and surprise to actually communicate complex new ideas. The Shannon algorithm calculates that exact balance. It loops through a text, counts how often a specific character appears, calculates the probability of that character showing up, and applies a logarithm to score the entire dataset. Now, I wrote a script to test this. First, I needed my extremes. I used Python's random library to generate 50,000 characters of pure meaningless alphabetical garbage, and then I ran the entropy math on it, and it spit out a high score of 4.7, which you can call maximum chaos. Next, I fed the script a raw text file of an actual English book. The structure of the language pulled the unpredictability down, landing at a score of 4.16. I ran a Latin text. Since Voynich is a European manuscript, it scored a 4.17. Finally, I loaded in the transliterated text of the Voynich manuscript. I ran the exact same math, and the script dropped a bar on the graph right at 4.02. The Voynich manuscript sits firmly in the mathematical pocket of human communication. It actually scores slightly lower than English, meaning it is highly structured. This isn't a medieval scam. It isn't random noise, and whoever wrote this was following a rigid, complex linguistic system. And that is honestly the most frustrating part of this entire experiment. The data science completely validates the book. We can mathematically prove that the author invented an entire custom alphabet and wrote a functioning, coherent language. But knowing the structure is real doesn't mean we can read a single word of it. Working on this just brought me right back to the realization I had with the Dorian gray pixels. Now, meaning isn't something that actually exists in the data itself. The data is just numbers. The pixels are just color values. Meaning is entirely dependent on the observer. It only exists in the shared hallucination between the person writing the code and the person reading it. Now, the Voynich manuscript is a perfectly encrypted file. The math proves the data is intact, but the only observer who possessed the key to actually read it, well, died 600 years ago. Until someone somehow cracks the syntax, the book is just going to sit there, just like static. Sorry for a late video. I've had some eye problems, that's why I couldn't make any new videos, but yeah, decided to cook this up once I started to feel a little bit better. Anyways, thanks for watching, and I'll see you in the next one.